Quantum gravity stands as one of physics' greatest puzzles. Scientists have spent decades trying to understand whether gravity follows the same quantum rules as other forces of nature. Think of it this way. We know electricity, magnetism, and nuclear forces all behave according to quantum mechanics, but gravity seems different. It follows Einstein's general relativity theory. So this is part of the quest for a single unifying string theory of the universe that says traditional physics and quantum physics and quantum mechanics are actually work together somehow, because historically they're at loggerheads and they don't work the same. So what do you think about this research and where it's going, John?
Well, this is cool because, so for those of you that don't know, gravity is the only fundamental force that's kind of not yet reconciled with quantum mechanics. So if it's proven that it's quantum, it could, like you said, revolutionize our understanding of everything from black holes to the Big Bang. So what they did, which this is cool, though, so they've achieved the world's first by applying a laser cooling to a centimeter scale torsional oscillator. So the torsional oscillator is a device that twists back rather than moving linearly. The oscillator, it's suspended, so it can rotate slightly, which makes it extremely sensitive to tiny forces, including gravity. So traditionally, such devices have been used in classical gravity experiments, but the innovation here from MIT is in the cooling and the isolating to such a degree that quantum effects could be observable. And they managed to cool the oscillator to just, and I've never used this term before, 10 millikelvin, which is a 1/100th degree above absolute zero, which eliminates almost all thermal vibrations and allows quantum mechanical fluctuations to dominate. So the ultimate goal here is to use such oscillators and see if they can become entangled via their gravitational attraction, their mutual gravitational attraction. So if gravity can mediate quantum entanglement, it would be direct evidence that gravity itself must be a quantum force and not purely a classical one, which would have crazy implications for physics, potentially confirming the existence of the graviton, it's a hypothetical quantum particle of gravity. I think we've covered it before. We've covered a lot of quantum stuff. And it rules out models where gravity remains fundamentally classic. What do you think about this, Craig? This is cool.
It's cool but we have, they're just setting up the test. We don't have any actual results.
No. This is purely just, they were able to cool it down this much. So they're the first step in setting up the experiment, if that makes sense.
Yeah, so to take it back a step, there's so much noise at the quantum level. There's so much noise at the quantum level. Sorry, my brain is slowly going this morning. At the quantum level, or the noise at the quantum level is so much that they liken this to hearing a whisper in a noisy restaurant. So using the laser cooling system, which is completely cool in itself, we know that lasers heat things up, but it's not traditional that lasers cool things down. Using the laser cooling system to get to near absolute zero at the individual atom level allows this to work with much larger objects and allows the quantum gravity experiment to push the boundaries of laser cooling can achieve. So they've cooled this down to such a level that there's almost no noise. And so you can start to now detect stuff happening at the quantum level. So they've taken about a centimeter size object, wrapped a bunch of mirrors around it, and pointed all these lasers at it and cooled it down to this microscopic level. And this oscillator detects any movement at the quantum level, and with all the lasers pointed at it, you measure that shift. So that's kind of how it works, and the whole thing is pretty cool.
Yeah, it is. And the reason why this is an innovation is because there's been previous proposals to test quantum gravity, but they required unattainably high energies or extremely delicate quantum states of massive objects. So this approach uses large but quantum coherent mechanical systems, which makes tests for this far more practical. So again, what are the applications of this? So beyond fundamental physics, the technologies developed here which is ultra-sensitive torsional oscillators and advanced laser control. They could improve gravitational wave detectors, quantum sensors, and even navigation systems, which we've covered as far as quantum navigation and different things like that in the past. So the next step, I don't know if you covered this, but they're aiming to further cool their oscillator to its quantum ground state, which I don't know what that means, and eventually set up two devices to test for gravitationally mediated entanglement. That means they're both entangled, which means one affects the other, if that makes sense, which means that gravity would be a quantum element.
So we'll only time will tell if they can prove that. But this experiment is very cool in a lot of ways. With these new techniques, the researchers have achieved 1,000-time improvement in noise reduction through this beam cancellation technique that we've discussed. The beam cancellation works by using multiple laser beams that interfere with each other. When done correctly, unwanted noise signals cancel out while the desired quantum signal remains. So the optical lever system acts like a microscope for motion. It takes tiny angular movements and magnifies them to easily detectable. That's why they have all the lasers focused on the oscillator.
Yeah.
So I like the fact that we are really taking leaps. We can do things we never done before, just like with the James Webb telescope that's out there and finding all new stuff in the universe. We're finding new genomes. We're making new proteins. We're finding stuff at the bottom of the ocean, and we're finding new stuff here. It's amazing if we can move our knowledge of the universe around gravity forward. I'm excited because what will that lead to?
Exactly. Yeah.
So let us know what you think about these gravity experiments. Do you think gravity is quantum, or do you think gravity is standard physics and this experiment won't prove anything? We'd love to know what your thoughts are and what this means for the future of quantum discovery.
Tired of drowning in repetitive tasks while your competitors race ahead? Every minute you spend on manual data entry, scheduling, and routine processes is a minute you're not growing your business. Flowgrammer.ca transforms your workflow chaos into seamless automation. We build AI-powered systems that handle your busy work so you can focus on what actually makes you money. Our clients typically save 15 plus hours per week and see their productivity double within 60 days. Visit flowgrammer.ca for a free automation audit. That's flowgrammer.ca. Stop working in your business and start working on it.
So what do you got going on, John?
Yeah, no, just working on a couple things with some partners. So have a look out for that coming up. But just helping companies secure government funding. So depending on when this comes out, there could be some programs open. Just have a look at my LinkedIn or reach out to me on LinkedIn. But if they need help with everything else with their business, how do they find you, Craig? What do they do?
Well, head over to torontostarts.com. You'll find all our events and many of our stuff over there. If you're looking for help getting your business moving, looking for coaching, looking for workshops and events related to the startup community in Toronto, check out torontostarts.com. If you're looking to do business automation and you're figuring out where AI fits in your business, head over to flowgrammer.ca. That's where we do AI and no-code automations with NAN and other tools. And we have meetups and events to educate and promote these types of technologies that people should be using. So check that all out. And people should find you on LinkedIn, John, for non-dilutive funding, like you mentioned.
Yeah, absolutely. Yeah, find me on LinkedIn the best way. I think I have a link that you can book an appointment directly through my LinkedIn. I think I have that set up. If it doesn't work, please let me know. But yeah, find me on LinkedIn.
And I know this is inside baseball for the people who are listening, but we're putting out videos as well as the audio files now, and they all go out separate schedules. So we're going to have, like, this will go out much sooner on video than audio. So we'll have to cover whatever when we're talking about what we have going on.
All right.
So check all our websites out. And if you're looking for what's open right now, is FedDev open, John?
No. So there is a FedDev stream that's open right now. Oh, sorry, FedDev. No. So what I found out with FedDev, they should have been open by now, but because of the federal election, they are not. So by the time this comes out, they might be open, but they should have been open May, June, but it's delayed because of the election.
All right. Check out, if you're looking for information on non-dilutive funding for your business, check out John Irwin on LinkedIn.
Thanks, guys.
And thank you, everyone, for listening or watching.